The first three component principles that we discussed in the previous video, REP, CCP, and CRP, was largely related to the cohesion in the component design. That is the relationship between classes inside the component and the architectural decisions about which class should be put into which component. That's why Robert Martin referred those principles as the component cohesion principles. The next three component principles are related to the relationships between the components. So we call them the component coupling principles. So, what are these principles? Let's see. Uh, ADP, the acyclic dependencies principle. The first one is ADP. The second is SDP, which is the stable dependencies principle. And the third is SAP, the stable abstractions principle. The acyclic dependency principle, ADP, is a principle that states that the dependencies between components in a software system should form a directed acyclic graph, DAG. In other words, the dependencies between components should not form any cycles, as this would create a vicious cycle in which changes to one component would require changes to another, which in turn would require changes to the first, and so on. By following the ADP, software architects can ensure that the components in their system are loosely coupled, which makes the system easier to maintain and modify over time. If components have acyclic dependencies, they are less likely to affect one another in unexpected ways, and changes to one component are less likely to cause problems in another. So, in a nutshell, the acyclic dependencies principle is an important software design principle that helps to create modular, scalable, and maintainable software system. And one important thing to remember here is that component structure cannot be designed from the top down. It is not one of the first things about the system that is designed, but rather evolves as the system's logical design grows and changes, as Robert Martin perfectly says in his book. So that's why he summarized the principle in one line as allow no cycles in the component dependency graph. The next component principle is the stable dependency principle, the stable dependencies principle. And in one line, we can say that it's about depend in the direction of stability. So the principle says that the dependencies between components in a software system should be in a stable direction. That is, the dependencies should be unidirectional and should not change frequently. Because as we know, designs of our system cannot be static. Some volatility is necessary. So the idea is that any component that we expect to be volatile should not be dependent on by a component that is difficult to change. Otherwise, the volatile component will also be difficult to change. So, by using SDP, the stable dependencies principle, we ensure that the modules that are intended to be easy to change are not dependent on by modules that are harder to change. This principle also helps to ensure that the components in a software system are loosely coupled, which makes the system easier to maintain and modify over time. And if components have stable dependencies, they are less likely to affect one another in unexpected ways. And changes to one component are less likely to cause problems in another. So, this principle again helps to create modular, scalable, and maintainable software system. By following this principle, software architects can ensure that the dependencies between components are predictable and stable, which reduces the risk of unexpected interactions and makes it easier to maintain the system over time. The next principle is the stable abstractions principle. The principle says that the abstractions in a software system should be stable, meaning they should not change frequently. So, in one line, Robert Martin put it as a component should be as abstract as it is stable. The SAP principle helps to ensure that the components in a software system are loosely coupled and modular, and that again make the system easier to maintain and modify over time. But the core idea behind the SAP is that the more stable the abstractions in a system are, the less likely they are to affect one another in unexpected ways. If the abstractions are stable, changes to one component are less likely to cause problems in another. For example, consider a system with a well defined stable abstraction for data storage. If this abstraction does not change, the components that depend on it can be developed and maintained independently of one another. If the abstraction were to change frequently, it would cause problem for the components that depend on it, as they would need to be updated every time the abstraction changed. SAP principle, in the words of Robert Martin, set up a relationship between stability and abstractedness. On one hand, it says that a stable component should also be abstract, and on the other hand, it says an unstable component should be concrete, since its instability allows concrete code within it to be easily changes. Thus, if a component is to be stable, it should consist of interfaces and abstract classes so that it can be extended. Stable components that are extensible are flexible and do not overly constrain the architecture.